Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. Okay, so first off, we're going to do something a little bit different. So we're going to continue our lesson from last time, and we're going to get a little bit trickier. Watch what happens. So we go from discs to donuts. Oh my goodness. Yeah, where is it? Here it is. So we're now going to do this problem, and we're going to get something with a hole in the middle, like this. So now we're going to fabricate some donuts. So write this problem down. I know some people complain about my handwriting. I apologize for that, but here's the problem right here. It's always on the PDF. Okay, so let's do it. Bam. Here's my jacked up handwriting. Same problem. So it says find the volume of the solid generated by revolving the region enclosed by y equals x squared plus 1 and the line y equals 5 about the x-axis. All right, first things first, we need a picture. We need a picture. So y equals x squared plus 1, that starts on 1 and it's a parabola opening up. Bam. Y equals x squared plus 1. Y equals 5. This is 1 right here. This is going to be 5. Y equals 5. So before we were rotating this around the line y equals 5. But now we're rotating about the x-axis. Ooh, okay. So the most important thing to do here is get your picture correct, okay? So we're revolving around the x-axis. So I need a mirror image right here. So once you get your picture right, everything kind of falls into place. So here is the mirror image right here, but I'm going to shade this a little bit because remember we always look at where the area we start with is for our radius, like last time. So when I rotate this, I'm actually you go from outside to outside, and then you go from inside the parabola to inside, and that's what creates our, in this case, it's a donut. Yeah. Infinite amount of donuts. It's got a hole in the middle. When you revolve that around, you can have a hole in the middle. You can just keep doing those, keep doing those, keep doing those, like that. Okay? So there's an infinite amount between these two places, which are -2 and 2. Because you set those equal to each other, that's what you get. Okay? So what I really want to focus on right now is how you get the volume of a slice. So now we have a hole in the middle right here. So this is new. And so first what we do, in order to get this volume or this area right here, this area, we got to find the area of the big circle and then cut out the area of the small circle. So we're going to take the area of the big circle and then cut this part out. Okay, so the radius of the big circle is this. So it's from y equals 5 to 0. So the area of the big circle is going to be pi 5 squared. Okay? Minus the area of this small circle. I'm going to take that out. So the small circle, the radius of that is everything that's underneath this parabola, right? So that would be the parabola. Pi x squared plus 1 squared. And so this is the area of the base right here, this face right here. All this needs to be times what? Oh yeah, dx, because that's the width right there, the infinitely small width. So now let's write our integral. So the volume of this fun shape looks like this right here. Here's a better picture of it. The volume of this right here is the integral between -2 and 2. So all of these slices, all of these donuts, infinite amount between -2 and 2 of the big circles minus the small circles, because that's the whole, dx. Cool? There you go. Nice job. All right, here's the next one right here. Oh, you can't read my writing? That's okay. Here you go. Here you go. Here are the two problems right here. See if you can do this one. Pause the video, see if you can get the integral. Ooh, see if you can get that one too. All right, here we go. Let me do it. Bam. Okay, So find the volume of a solid generated by revolving the region enclosed by y equals x squared and y equals 8 minus x squared in the x-axis. Okie dokie. No problem. So y equals x squared is a straight up parabola, looks like that. Bam. Y equals 8 minus x squared. Start at 8, and then it's an upside down parabola like this. So this is the region right here. Okay. First things first, you need a mirror image. Get your mirror image going. Make sure the mirror image right there of the area. Okay. So then you go top all the way to the bottom like that. Then you go middle to middle. So there's a really small inner circle right there. And then here the inner circle is a little bit bigger. Boom. And then you just keep drawing these to show what's going on. And there's an infinite amount of those. Infinite amount of those. Okay, so now we're going to find our volume of a slice. So that's the area of the big circle minus the small circle we're taking out. So the radius of the big circle. So that's from, I always like to do one on the outside because it's a little more clear than one on the inside. So this is this graph to the origin. So that graph to the origin. So that radius right here is going to be 8 minus x squared. And then the small circle right here, this radius is from y equals x squared to the origin. So that's everything underneath that. So the small radius right here, we'll call this one big R, and then the radius is small r. So that's going to be x squared. So the volume of a slice is going to be big circle pi r squared minus pi r squared times, yeah, you're right, dx. So that's the width right there. Okay? So we're going to have the volume of the entire thing is the integral between what and what. Okay, what are these intersection points? See if you can figure them out if you haven't already. See what we got. Okay, so that'd be 8 minus x squared equals x squared plus x squared plus x squared. 2x squared equals 8 divided by 2. 4 equals x squared. And so x is going to be plus or minus 2. So this is negative 2 and this is positive 2 where they intersect. Okay, so it's negative 2 and positive 2. All these donuts in between is pi 8 minus x squared all squared minus the smaller circle dx. Sorry, dx at the end. Oh, there we go. Did you get that? Let's see if you get the next one. Here you go. 2 more. Doing good. All right, here you go. So the volume of a solid generated by revolving the region enclosed by y equals x minus 4 and the y-axis and the line y equals negative 2 about the x-axis. Okay, let's draw a picture. First thing, picture is so important with these. So important. Y equals x minus 4. So we go 1, 2, 3, 4. Something like that. So this is negative 4. And then y equals negative 2, so this would be negative 2 on the y. So this would be my line right there. Y equals negative 2, and it's enclosed by the y-axis, so it means all this area right here. Okay, so I'm revolving this around the axis like that. So I need to draw a mirror image like this. Mirror image like this. Okay, so outside to outside, inside to inside. That's a smaller circle. Outside to outside, inside to inside, etc. Okay? So it should look like that. So, So in this case, where was the original area? Down here. So this is the original area down here. So I'm finding my radius from the bottom. You always start where the actual area is. Don't start where your mirror image is, okay? So this radius, the big radius of the big circle, capital R, that's going to be from the diagonal line up to the x-axis right here. So that's going to be the big radius. So that's going to be everything under x minus 4. And then the small radius here, this small radius is going to be everything underneath y equals -2. So that's just -2. Bam. All right, so the volume of a slice is going to be pi, big circle, remember, x minus 4 squared minus pi times -2 squared dx, which is the width. Sorry, I forgot to make it three-dimensional. Bam. dx. Okay, so now I need the whole volume. So that goes from 0 to this point right here. So 0 to this point. So that would be when, what was that point? Do you know? X minus 4 equals -2 plus 4 plus 4. Set the equations equal to each other and you get 2. So it's between 0 and 2, because this point is 2, of pi, the big circle, squared minus cutting out, -2 squared is 4. So I'm going to do 4 pi dx. You want to do something like that. Okay, here's the total volume. Cool. Excellent. All right, I think we got time for one more. Nice job, boys and girls. All right, so here it is. Check it out. A little trickier, squared. Oh my goodness. So write this one down right here. Find the volume of a solid generated by revolving the region enclosed by y equals x squared plus 1 and the line y equals 5 about the line y equals 6. Damn. All right, let's see if we can do it. I think we can. You can pause the video and see if you can figure it out for yourself, because it's always good to do that. Always just try stuff. See if you can do it. So a little bit trickier. All right, picture first. Y equals x squared plus 1. Looks like this. Okay. And y equals 5. Looks something like this, let's say. And we're revolving this region around the line y equals 6. Damn. Y equals 6. So we want to dot it. To differentiate what it is, this is y equals 6, y equals 5, and this is y equals x squared plus 1. So I'm revolving this piece right here around here. Okay, so looks like this. So I'm drawing it right into my problem, but that's okay. That's okay. So here's big circle, small circle, big circle, small circle. So here you go. Big circle, small circle. Okay. So we always go from the original region, which is this, okay? And so this part right here is our big R. So from this line, y equals 6, down to our parabola, that's the big R. That's this piece right here. And so this is 6 minus this. So it's top minus bottom. Top minus bottom. So the big R is 6 minus the parabola. Ooh. And then my little r right here, my little r, the radius of the small circle I need to cut out, that's going to be from 6 to 5 right here, from 6 to 5. So see, from 6 to 5, bam. So that's 6 minus 5, top minus bottom. All right, so let's set it up. Volume of a slice is going to be pi, big circle squared, so that's 6 minus 1, which is 5. And this is minus x squared. You want to get fancy. Squared. Minus 6 minus 5 is 1. Minus 1 pi times 1 squared dx. Okay, so now this, we got this one before. This was 2 and -2, because when you set x squared plus 1 equal to 5, you solve, you get x equals plus or minus 2. And this is going to be -2 and 2, the infinite amount of donuts that go in between, which is pi times 5 minus x squared squared minus pi times 1 squared is just pi dx, and that is the total volume.